Welcome everyone to this webinar, the Conventional Row Crop Farming 101 webinar. My name is Nathan Albert with the Liberty Prairie Foundation. Really glad you could join us. Very glad that Rob Woodrow and Kent Kraft from Farmland Solutions are here to help us out as well. The intent of this webinar is to enable you as farmland owners to better understand the conventional farming system so that when you are in a situation where you want to work with your current conventional farmer or another conventional farmer, you know where they're coming from in terms of the system they use, the equipment they use, how more conservation-oriented practices might be a challenge for them. So you can do something collaborative with them and help them move, hopefully incrementally, in the direction that you want to go in. I was looking at the registration list this morning, and we have public farmland owners, private farmland owners. We have some nonprofit advocate groups, and we also have some nonprofit land trusts. Between all of you, we have somewhere just south, I think, of 15,000 acres of farmland that's under your direct ownership and management. That's a lot of farmland. And then indirectly, through your advocacy and the model you set, you are also able to influence a lot of other people. So I'm really excited about all of you joining us. Before I dive in, I want to share some background information with you. I represent the Liberty Prairie Foundation, a nonprofit organization with our own 94-acre organic farm here in the Prairie Crossing Conservation Community in Grace Lake, Illinois. We use our farmland and our services to demonstrate, support, and promote sustainable farming. I, in particular, along with my colleague Jim Kurchadina, sort of operate the Northeast Illinois FarmLink program, which is a land access program. It's designed to bring together farmers and farmland owners to work out mutually beneficial land tenure agreements. You can find us and our farm linking service, our website, at illinoisfarmlink.org. I also want to sort of give special thanks to our funders, and in particular our funder, Food Land Opportunity, localizing the Chicago food shed. Flow Food Land Opportunity is a multi-year funding initiative between the Chicago Community Trust and the Kinship Foundation. Its goal is to create a resilient local food economy that protects and conserves land and other natural resources. We are super grateful to them. They are doing really important work throughout the area. I want to give you a few tips. Again, if you have questions, use our the chat function at the bottom of the screen. I do appreciate everyone being muted so that we don't get feedback and other background noises. We have over 20 participants, I'm glad to say, which is awesome. We will not be able to get to every question, but I'm happy to say that after the second session on Thursday, Rob and Kent have said they'd be super happy to take your questions and calls that you might have after this call. So we're grateful for that. Before we get to Rob and Kent, I also want to sort of ask Ed Collins to say a few words. I want to provide a little bit of a background to this. Our conviction is that farmland owners have generally been overlooked in terms of the contribution they can make towards moving our farmland system in Illinois and the country towards farming that's better for land, for farmers, for communities, and for the food that we eat. And so when we started thinking about farmland owners, we focused on public farmland owners initially because they have so much land and they already have a conservation mission. We've been very fortunate to be able to collaborate and offer some assistance to the McHenry County Conservation District. They have 6,000 acres of farmland under the leadership of Ed Collins, who's on this call, the Director of Natural Resources for the district. They've been really revamping and rethinking how they manage their farmland, and it's really excellent work. And in fact, this webinar session is actually Ed's idea. So if it goes well, Ed, you get some credit. And if it goes south, you get some credit as well. So Ed, would you mind just sharing a few words about the value you see in this webinar series?
Thanks, Nathan. And I want to give a shout out to Brad Woodson, who's here as well. Brad is the manager of natural resources for the district and works in my division. And this is really part of kind of a process that started a couple of years ago. We have a pretty good handle on the natural resources that exist in natural areas at the conservation district. They're extremely well studied. We know what's out there. We know where we want to get to. But we came to realize that we didn't have anywhere near that level of understanding of what was going on our farmland. So we began working with a variety of partners, Nathan and Liberty Prairie Foundation being one of the primary ones a couple of years ago, to figure out how to develop a digital framework for tracking the ecological health of that 6,000 acres of farmland. And we're moving closer to completing that. And eventually what is going to flow out of it is what we call the Agricultural Conservation Index, which is actually a numerical formula for seeing if our properties that are in farming are getting healthier, staying the same, or whether they're degrading. And kind of central to understanding that and to being able to incorporate more regenerative farming practices into our program is in a clear understanding of what is involved in conventional agriculture. And I think that is both a series of processes that occur on the land itself between the operator and the land, but it's also understanding agriculture as what it truly is. And that is a business that has to have a profit in order to stay a business. So one of the things I think is lacking for a lot of public agencies, and I'm going to include my own in there as well, and one reason why we have this webinar today, is a lack of understanding of the basics that go into what we call conventional or modern farming. We're all aware that it's on the landscape. We all are benefiting from its products. As open space conservation agencies, we often don't have any problems talking about the issues that are related to it. But I don't think there's a general awareness of what farm operators face, what processes they have to get done at what timing in order to make a crop and make a profit. And that is for a couple of reasons. It's really not part of our mission generally. As conservation organizations, we often look at farmland as something that is a transitory stage between purchasing land and restoring it to a different kind of habitat. But I also think that as open space agencies, that puts us in a very unique position to be able to experiment with regenerative agriculture, and in some ways to even be able to subsidize some of the practices and find out how they work. And I believe that our agency, like many in these times, is going to be involved in farming for a long, long time, decades. So the better we take care of that land, the better we understand how farming interacts with those ecological processes, I think the better we're all going to be. So this was when Nathan said, what would you guys like to learn about? A bunch of really good ideas came up, and one of them was, okay, what's exactly involved in conventional ag? How can we understand it better? That's our starting point. So I will mute myself at this point.
Okay, thank you so much, Ed. So now I'd like to introduce Rob and Kent with Farmland Solutions, LLC. They both grew up in farms, so farming is in their blood. Kent grew up and farmed in Iowa, Rob in Illinois. Kent had a 10-year farm career. Rob spent 10 years with the USDA in various capacities. And between them, they have 53 years of experience in farmland management. And I thought, as a farm management company, they were in a unique position to talk to us today and share information about farming, because they work both with the farmers, they have to know their farming, and they also work with farmland owners, who you are. And so they know the concerns and knowledge and maybe the blind spots of farmland owners and how to explain those things and communicate about those things. Their firm manages 177 farms representing 60,000 acres. That includes Central Illinois, Minnesota, Wisconsin, Iowa, and South Dakota. They were also one of the first independent farm management firms in Illinois to get into the organic farming business. And that is, interestingly enough, a reflection of the demand they had from farmland owners who said, we want to go to organic, which is really interesting. And so they have 4,100 acres certified or in transition. Again, I've really enjoyed speaking with them. Offline, I moderated a panel with Rob Woodrow at the Illinois Organic Grain Conference some time ago, and was really struck by his knowledge, his straight ahead style, and his sort of understanding of farm landowner psychology. Kent and Rob, thank you for doing this. And Ken, thanks for inviting us into your home. Please go ahead.
Okay, with our first few conversations by email and by telephone on our assignment here, the assignment was pretty much just take a group of people with a superficial knowledge of agriculture and teach them everything they need to know. And my first reaction was no. I said you'd have to be crazy to try that in one or two webinar sessions. And I thought, well, you have to be crazy. Maybe we qualify. So we decided to go ahead and give it a try. We're going to go ahead and share our screen. So we're going to disappear. Hopefully.
Click share, there you go.
And get this started. Okay. I'm Kent. I guess I should have said that in the beginning. Rob here to my left, and we are going to tag team this presentation. I'll start off, go through a few things to get us rolling, and we're just going to jockey back and forth, give each other a break as we move through this. It's going to be largely an information dump. We've got a lot to cover. You may find out you don't learn as much as you learn what you don't know. We can't obviously get into a lot of detail on every topic. But what we have here is an agenda just to start with a little perspective on agriculture, focus a little bit on what makes Illinois a little more unique. Then we're going to dive right into row crop farming, what practices happen, when they happen, and why they happen. We'll finish up with a fairly quick discussion on the current agricultural issues that we're dealing with. If we have time, we'll take a quick look at what I think we're going to need to address in the future, and then hopefully have time for questions and answers. And then we're saving some other details on the economics, budgets, leasing, farm program, and such for Thursday. We've already covered that. I want to address a little bit our profession. I find that when I talk to people who have no or little exposure to agriculture, and I tell them I'm a professional farm manager, they get a bit of a blank look on their face, and I know that they have no clue as to what we do. So the analogy that I come up with quite often is to say we really are the same function as an apartment manager does for the owner of an apartment building. We sign leases, we collect the income, we pay bills, we fix things that need to be fixed, we solve problems, and we are an agent, fiduciary agent for the owner. In our case, it's not the owner of the apartment building, it's the owner of farmland. We've been in business since 2009 together. We worked together for a bank before that. That's what brought us together. We've covered, Nathan covered a lot of those details. So we're going to start with, to talk about where we are now, we want to talk a little bit about where we got, how we got here. And it's remarkable if you think about it. The human race has existed somewhere 200,000 years, 300,000 years, but it's only in the last 10,000 that we've had a history of agriculture. Before that, the human race were hunters and gatherers. If you can imagine what it was like when people started to plant their own crops. Of course, we don't have any pictures. The cell phones were pretty scarce back then. So, but we can imagine they were probably poking a hole in the ground with a sharp stick and dropping a seed in and stepping on it to seal the hole. At some point, somebody figured out that they could get a better result if they just stirred the ground a little bit by dragging a stick through the ground, which was a lot of work. So someone would have made the leap to making an animal drag that implement through the ground to loosen the soil for growing crops. And if you think about it, what's remarkable about having an animal drag an implement through the ground, I'm 65 years old, born in 1954. My father was just 29 years older well, he was 29 years old when I was born. He was in on the very end of farming with horses. He can remember as a young boy, his job was to get the winter coat off of the horses in the spring when they started to shed. As a result, he hated horses the rest of his life. If you've ever done that, you understand why. But anyway, getting back to our topic, we're moved into a new phase of mechanization. We have machines like this. We've added air conditioning and a radio, but in effect, what we're still doing is dragging a stick through the ground in order to prepare a crop. So at this point, I'm going to have Rob take over.
And when you look at that tractor with the cab, and Kent talks about the air conditioning, last night my oldest son had been in the field a little bit yesterday afternoon, and the air conditioner wasn't working. So that was high priority last night to get the air conditioner working in the tractor. So what's made Illinois agricultural successful? Our soils, our climate, our markets, and our transportation are the main things that really makes Illinois successful. Our soils are mainly heavy prairie soil. Our climate, we have a good change in weather from spring, winter, fall, and such, in which makes it good for soil and growing crops. Our markets, of course, we have the Chicago Board of Trade, which is the benchmark for all commodity markets, and our transportation system in Illinois with our rivers, river barges, trucks, and trains. That's why Illinois is the #1 exporter in soybeans and #2 in corn, is because we can move it efficiently off Illinois into the world market. Illinois soils, there's hundreds of soil names in Illinois. Most of them vary by proportions of sand, silt, and clay. Most of them are named by where they're primarily found. Prairie soils, which cover basically everything north of I-70, is been affected by the glaciation and mainly improved by drainage. The high fertility, high organic matter, and our topography allows water to run off to some extent. And every soil in Illinois has a productivity index that's based off of the what kind of crops will produce, the crop yields, and that is used to base our real estate tax system on. So we got to worry about how the taxes are, and that's a uniform system for that. Our weather, our water temperatures and freeze thaw cycles, because we are at many times at the meetings of the warm and cold fronts coming up and across the continent. The clashes gives us good ample water supply most years, and gives us a good wide temperature swings, and of course our freeze thaw cycles that help with the breaking up of the soil and such. Water table management. Illinois was a swamp. Some parts of it still are. Subsurface drainage was started about 120 years ago, maybe a little bit longer, using clay tile to lower the soil water table. And generally now it's moved to plastic tubes that are perforated tile that installed 30 to 36 inches deep, that outlet in river, creeks, and man-made ditches. The drainage dramatically improved the yields and efficiency. Roots don't grow well in saturated soils. We saw that last year. You saw that a lot in northeast Illinois, because a good part of that area just went planted last year because of all the excess water.
So if you've driven across Illinois, you've probably noticed that there's a pattern. There's corn on the left and beans on the right, or maybe there might be corn on the right and beans on the left. And you might wonder, why do we just have those two crops? So I can answer that question. Well, why not? We've got the infrastructure in place. If you can make an adequate profit growing those crops, it makes sense to do so. We have all those comparative advantages that we've been talking about with the markets, the transportation, the soils, the weather. So it's two crops that just have come to dominate what we do. Corn and soybeans is primarily what we're going to talk about. That doesn't mean there aren't other crops. Rob and I both have some oats and wheat growing this year, but they're fairly minor compared to the acres of the corn and soybeans. So we'll focus on those. So we're going to take you now through a crop year cycle, and I hope I'm not insulting your intelligence by taking you through some of the basics, but we'll start here quickly. And the crop year cycle will start in the fall after the previous crop is gone, because then you have to prepare for the next year. So fall and winter, you're talking about applying fertilizer if it's needed, maybe doing some tillage, maybe not doing tillage. In spring, again, you either continue the tillage, or if you've chosen not to do any tillage, you don't do any. But that's when you're going to plant. You're going to have to control the weeds somehow, either chemically or mechanically. In late summer, you still have a chance to do some weed control. That is in the summertime is when the fungus starts to affect your crops. That would be when you would apply a fungicide if you think it's needed. Farmers will be making their yield estimates to see what they have to sell in the fall. In the fall, they harvest it, either store it on the farm or store it elsewhere, transport it elsewhere, and that would finish out that year. Now we're going to go back, take another dive. Just say some of these drone photos are I've taken with my drone of farms that I manage. This is one of them. But again, as I said, we start in the fall, and the first question you come up with is tillage. Are you going to till the ground or not? We're going to get more into detail on that later. But then you have to decide not only what are you going to grow the next year, but what are you going to grow the year after that. You may want to make some accommodations to make sure you're farming using a system and not just starting over again every year with whatever might work. We're going to talk in more detail about the seed choice. There's multiple factors that affect what you're going to buy when you harvest, what your market is by what seed you buy. Weeds are always an issue. If you go to an organic seminar, most of the organic farmers will say that they deal with their three worst problems, and number one is weeds, number two is weeds, and number three is weeds. Fertilizer is an issue for all crop production, and we're going to get into that in a little more detail. So I practiced this presentation on my wife. She grew up in the city, and I was quite startled to find out she didn't know what the word tillage meant. So hope we're all clear on that we're stirring the soil. Yeah. And why do we do that? Rob, you want to just get into that?
Well, there's several reasons, and it's speed to crop residue decomposition, which is going to release some stored up fertility within the dead crop residue, kill weeds, loosen soil for water and air infiltration, improve the ability to warm up, dry out in the spring, and make the soil texture more uniform. Downside of tillage can be excess tillage destroys the soil structure, which we're seeing a lot of that now. We're learning more about it. It disturbs the beneficial fungi and bacteria, the mycorrhizal fungi. In dry years, it can excessively dry the soil with no rain. When there's no rain, it decreases soil organic matter by oxidation of the organic matter and releasing the carbon back to the environment, because that's what organic matter is stored carbon, and it can allow for more erosion. Fall tillage, if it's done, can be done many ways. We started out earlier in the slide showing a moldboard plow. I'm not going to say that there isn't any moldboard plowing done now, but it's from when I grew up, that's what I did after school every evening. When I got home, was get on the tractor and plow, and as soon as corn was harvested, I was out plowing. Now it's chisel plows, deep rippers, and such. And in the bean stubble, it's just a light tillage that will either be control the weeds or whatever. In the spring, again, if a person chooses to till, we till to get a uniform soil texture, level surface to make it smoother for the planter to run, kill the weeds. And it used to be important to incorporate herbicides, but now most of the herbicides are laid right on top of the soil.
Yeah, Rob, if I could jump in here, I picked this photo. I just grabbed it off the internet. If you look at that machine, it's doing 3 different actions. The first is a concave disc that's going to throw the soil sideways. The shanks below, they have some spring to them, so if they hit some obstruction, they won't break, but they will mix the soil. The structure on the back, we call that a rolling basket. It will function to press the soil back down into a more level surface to prepare for planting.
Vertical tillage has become a very popular application in the fall now. It ploughs the soil rather than stirs it or inverts it. It leaves a higher amount of crop residue on the surface. It runs at a shallower depth, so it doesn't disturb the mycorrhizal fungi and bacteria as much, and it can be done at a much higher speed, so farmers can cover acres faster and use less fuel.
Again, if you look at the machine, it's a series of coulters that they're not concave. They do have a wave to them. They do chop up the residue, but they're only disturbing the top inch or 2 of the soil, which is why they don't use as much fuel, or they can move so fast.
And then one of the things there where it says leaves a higher amount of crop residue on the surface, you don't need to change it again. Okay. That's why you also see more corn stalks and soybean stubble floating down the creeks and rivers, because it does make it easier for them to move, unfortunately. But it also leaves it on top to help armor the soil from heavy winter rains and wind.
Okay, we're going to shift gears a little bit and talk about fertilizer. The crops that we grow are generally exported off of the farm. In years past, a lot of that got recycled through livestock, and the manure went back onto the field. Livestock is not as prevalent in the mid-Illinois area or a lot of the Midwest. A lot of it's moved to the southwest part of the country. So we're talking about exporting a lot of the minerals out of the soil. The primary mineral fertilizers would be phosphorus and potassium, to a lesser extent sulfur. The nitrogen, the air we're breathing is mostly nitrogen, but that is not a form that corn can use as a fertilizer. Sulfur is sometimes referred to as more of a micronutrient than a macronutrient, but what we found that as we've put the coal power plants out of business, they're putting less sulfur in the air, and we're seeing a need for sulfur to be added in the part of our fertilizer mix. So what we're shooting for is applying the amount of fertilizer that will replace the nutrients that are removed when the crop is exported. If the soil is deficient in some nutrient, we're going to add a little bit more to build it up into a more of a optimum level. If there is more than enough fertilizer left in the ground, we may apply less fertilizer, so we're not wasting money. The micronutrients, there's a long list. Boron, magnesium, zinc are some that are not unheard of to apply them. Here in the Midwest, we generally don't have to apply micronutrients. The biggest proponent of application of micronutrients are in this area anyway, I think, are the micronutrient salesmen. The soil pH it's not really a fertilizer, but it's a soil condition that gets addressed at the same time in your soil test. We're shooting for a pH 6.5 to 7 as an optimum range. If it's below 6.5, you probably will improve your yields by bringing that pH back up. You do that by applying powdered limestone, which is gravel, basically ground up, and mixing that into the soil. The way you find out what your soil nutrient level is to send a sample off to a lab. They will send, they'll take a sample, they will dry it out, they'll grind it up, and the amount, after you send them 50 pounds or so of soil, each sample location is getting about a teaspoon of soil that actually gets tested in the laboratory. That little teaspoon of soil represents a whole lot of dirt. So you have to think that it's not going to be exactly accurate, but it does give you a good indication. We are trying to test at the same location every time we do test, which is about every 4 years. It's not going to come out exactly the same, even if you took your sample, an inch away from your previous sampling site, but it should be, if the tests are accurate, tell you whether that location is high, medium, or low in the various fertility factors. Who does this? There are private labs. If you're buying fertilizer from a local dealer, he will sometimes pay for the testing and then tell you what you need to have applied. A lot of farmers deal directly with the labs. The labs have their own sampling equipment with the ATVs that run in the fields to take the probes down about 7 inches, which is where most of the roots are of the crop soil, or the amount of soil where the roots are for that crop. One thing I wanted to mention, it might be counterintuitive. You may have an area that's very low in fertility, but it's very high in yield. And the opposite could also be true. You might have very low fertility, or excuse me, high fertility and low yields. So that your fertilizer levels are not the primary indicator of what your yield is going to be. Probably drainage and soil type and structure is going to be much more important. If you've got a high yielding area with low fertility, that's because those high yields have sucked all of the available nutrients out of that ground. The soil will naturally replenish itself. A lot of the available nutrients, let me back up. There's more unavailable nutrients in the soil than available nutrients. As you suck the available nutrients up, the unavailable nutrients then will mineralize and become available to the crop.
We're finding how important soil biology is to that now in the last few years. So,
fertilizer comes pretty much in 3 different forms. It's gas, liquid, or a solid, a granular like sand. I've got a picture there on the left of an anhydrous ammonia applicator. This ammonia gas is under pressure, a couple 100 pounds per square inch. It's a very toxic substance. If you got a whiff of it, you might end up in a hospital or have some skin damage. Farmers don't really like handling it, but it is the least expensive form of adding nitrogen. The gas is injected into the ground. It's absorbed very quickly by the moisture in the soil. If you see some white vapor coming up behind the row, it's not unusual, but it does represent some loss of that gas that gets injected. The phosphorus, the potash is usually applied as a granular. The machine on the right has a boom that is powered by air pumped through there that carries the granules with it. It gives a very even distribution across the ground. There's an alternative method that just has a spinner, just like you might use in your lawn for spreading lawn fertilizer. It would just toss it out there. It also does a good job. You might not get as even a distribution with a spinner. Fertilizer can come as a liquid, and you would just have a change of equipment with having a large tank or tanks on equipment such as this.
In the last 30 years, no-till planting has gained quite a bit of acceptance across the Midwest as farmers have moved away from moldboard plow and some heavy tillage. And no-till farming will leave you a high residue on top of the old crop. And then they've also developed what they call strip till, which is they'll go in the fall and make a strip, apply the fertilizer, in that strip, and then they will come back in the spring and plant on top of that with the GPS equipment. Technology has really allowed that to come on fast. With no-till and strip-till, you need a little bit heavier duty equipment because you're dealing with heavier residue, which can tear up the system. No-till planting generally requires a different weed control system, and the soil adapts to no tillage over multiple years. You ask, why does it need a different weed control or require a different weed control system? Well, because you're not incorporating the herbicides, you're spraying it on top. And weeds grow from different depths of soil, and there's what we call a weed seed bank in the soil that if you disturb it, you're going to bring up seeds that's going to germinate from maybe 20 years. So the pattern changes with the tillage practices you do. No-till challenges would be curing compaction in wet years, just like we saw this last fall. A lot of ruts and such because of the wet harvest. And again, the weed spectrum changes because of what weed seed are either being left on top or brought up versus not bringing up. So social pressure isn't nearly as much as it was 30 years ago when farmers first started no-tilling. There's been lots and lots of different modifications for the planters to allow for no-till, and some owners ownership of tillage equipment creates a desire to use it. I know when my boys started farming this year, the best way to do it was not buy it. So so they're doing no-till. There's a picture of a conventional farmer or conventional planter. Dirt's all worked up, planting the corn or soybeans in the fresh dirt with the planter.
One of the things you might not think about if you have decided to become a farmer is how wide apart are you going to plant your rows. Originally, those widths were determined by how wide a mule's hind end was, about 40 inches. That still went into probably the 1940s and 1950s when tractors had pretty well taken over, and farmers figured out that they could narrow those rows to 36 inches apart, and the tractor tires fit well between those. Then universities started coming up with some research that said, yeah, we can go ahead and go to 30 inches. Tractor tires still fit in between the rows. And by crowding a little more plants into an acre, we're getting higher yields. We've gone to some 20-inch rows occasionally with some operations. I have to say of the two farmers that I work with that went to 20-inch corn rows, they both moved away to wider rows again. They did not see the benefits, and there were some downsides to having the corn that narrow. One is that the air movement was not as good. They were seeing more fungus coming up in that corn.
One of the benefits of a narrow row, though, is the plants are spread further apart. You know, if you're going to plant 36,000 seeds per acre, when the row's a little bit narrower, the seeds are a little further apart in a narrower row.
Soybeans don't have the same limitations that corn does. It's very common to see them planted in 15-inch rows. That gives the early canopy that Rob just mentioned, covers the ground, and that's good because weeds don't germinate unless they have sunshine. If you plant with a grain drill, that's the machine that used to be, or is still used for planting small grains, oats, wheat, barley. Those seed openings are 7 or 9 inches apart in general. With one of the downsides to going to very narrow rows is for the same number of row units, you have a narrower machine. You're going to need to make more trips across the field. You're going to have few acres done per hour. Weed control, that's a whole university degree. We're going to cover it pretty quickly. This is a picture of a row cultivator, and it's doing tillage, but it's doing very light tillage in between the rows. The weeds that are growing in the row will hopefully be caught when they're small enough that the dirt thrown by this machine would throw the dirt on top of the weed and suffocate it, and your crop is hopefully tall enough that it would grow through it. These have become pretty rare. Farmers have gone to chemical control instead of the row cultivation. They're spraying multiple times during the year. Sometimes it's for bugs, sometimes it's for weeds, sometimes it's for fungus, sometimes all three. Or you could add a possibility of adding foliar fertilizer. The machine on top there with the tall, narrow tires can go through some fairly tall crop. There is a point where that might not be tall enough for a high corn crop, and then you send in the airplane to spray. But generally, that's your last trip through the field until you do the harvest.
Hey, Kent?
Yes.
Can I just take a brief pause here and just ask if anyone has any questions they want to share in the chat room? One question I had, you had talked about no-till and how the soil adapts to no-tillage over the years. Can you say a little more about that? What do you mean by the soil adapts?
Well, one thing you'll see is more earthworm activity because you're not destroying their home. You'll see more, the earthworm activity they'll come up and they'll digest some of the plant material, take it down into the soil with them to store it for feed, which helps in filtration. And I mean, that's one of the main things you see. But you also see the soil change in its property some. It can either become harder from excess fertility and chemical use, or it can become more palatable is the word I'm wanting to say, but it becomes looser and more forgiving. It really depends on the year and how a farmer treats it, and whether it's too wet when he's working it or too dry or such. So it just changes. It can actually change it. The other problem it can do is if you have to use lime to correct the pH, sometimes that lime doesn't get mixed into the soil or won't get mixed into the soil, so it doesn't do the correction that you're looking for it to do. So those are certain things we see with long-term no-till. When
no-till first started in the 1960s and 70s, I think a lot of farmers tried it for a year or two and then gave up. They had a wet harvest maybe where the soil was compacted. They didn't want to use the plow to loosen that soil again, so the ground stayed hard. If they'd have stuck with it for 3 or 4 years, the earthworm activity, the increased organic matter, whatever else is affecting it, would have taken over. They would have restored that soil permeability, and it kept improving from there.
The freeze-thaw cycle has a lot to do with it also.
Okay. We have another question. Would you be able to share your thoughts about soil testing for carbon content and biology? So obviously, the soil testing you mostly talked about were nutrients. What are your thoughts about the value of testing for carbon content and biology?
Well, the Haney test, which tests for carbon and for soil biology, is relatively new. I think it's a great concept. Been using it a little bit on our organic farms to see what changes are happening. Still a fairly relatively expensive process, and timeliness is real important to get it to the lab. I think it's got a lot of potential to help us manage those soil biology and carbon sequestration in the future.
We know that no-till will sequester the carbon in the soil. We know that tillage releases it. So you can make some argument that we know what it does. We don't really need to measure it, but it would be good to, as we're talking about this test, to have some numbers. If you can't measure it, you can't manage it, I guess.
Right. My additional question, I guess, would be, can you say a few things like what are the top 5 weeds in Illinois that you see? And then number 2, I have a friend who's a conventional farmer, mostly conventional, and he actually has nightmares about weeds taking over his fields. I mean, actual nightmares. And can you talk
about for organic then, is it?
Can you talk about the top 5 weeds and then that psychological pressure to control weeds?
Yeah, we've got a slide coming up that we're going to circle back and
Okay,
kind of go back
okay.
through the whole cycle again with it a little more
Okay.
detail. We're going to
Got it.
probably pick up speed here a little bit. So
Okay. Got it. I'll let you know.
seatbelts in. We're going to keep moving.
Okay, sounds good.
You got some, okay, this is the final step after the combine. You got to get it to market somehow. And this is usually how it happens with an auger wagon that follows the combine. The reason for that is to keep that combine moving. It never has to stop. The auger wagon, it can take it to the edge of the field. You can leave your truck on a hard road or a more compacted end rows or driveway to make sure it gets out of the field in a wet year.
Goal is to keep that $400,000 combine moving. Doesn't make money if it's not moving. So.
Okay, so there's a finishing up of a crop cycle. So if you can hold off on the weeds for the next topic, I do want to get into the seeds as part of the way our presentation is designed.
Sure.
Since we talk mainly about corn and soybeans, the hybrid corn is a cross between two purebred lines. It results in a hybrid vigor. So you can't, I say you can't, you generally don't take the corn out of the grain bin, clean it, and plant it because of it has lost that hybrid vigor. Soybeans are bred for uniform characteristics. They're bushy plants, and there's upright and narrow leaf types. The difference, one of the main difference between corn and soybeans is time to maturity. Corn grows by heat units or growing degree days, and soybeans flower and mature based on length of nighttime. So corn generally takes about 2,500 growing degree units to mature, and soybeans then are mature as the days get shorter in the fall. That's when you start to see the leaves drop and mature, and there are different maturity lengths of both corn and beans. So genetically modified or not, a farmer can benefit from herbicide resistance and insect resistance by letting the plant control those problems versus having to spray additional products. Consumer benefits, those are somewhat questionable yet. We don't know 100%. There's arguments that because we've added a protein to the plant that's not natural, that it affects the digestive system of both livestock and humans. And I'm not going to comment. I haven't no 100% verification on any of it, so I'll just leave it at that. Seed treatments, almost except in the organic world, all seed comes with a treatment on it. It helps you plant earlier in the spring in the cold soils. The seed is more vulnerable to insects and rotting and such. And but there's concern about some of the insecticide coatings killing the pollinators,
Nicotinoids.
Thank you. The pneumatic delivery system of the seed to put the seed into the ground through the planter. Concerned about that, blows up into the air and can affect some of the pollinator insects. Plant populations, genetics have affected the rates. The highest yield potential for corn is depending on the soil type and the ability for it to supply a crop is between 30 and 40,000 plants per acre. In soybeans, with improved germination and genetics, has actually allowed for lower populations of soybeans with 140,000 plants per acre, now considered a high population. Uniform emergence is really a key to achieving the highest yields in corn and soybeans.
So now we're getting to the weeds. As we say in the organic world, it's biodiversity. It is a weed that you would prefer that is not there. The top photo that is the tall water hemp that we didn't really see until we got into the 1990s. It kind of moved in from further south. It has a nasty relative, the Palmer amaranth, that is like the water hemp on steroids. It gets a stalk as big as my arm. And, with the water hemp, you could chop that off with a hoe. With the Palmer, it generally would take an axe or a chainsaw, even is what people are using to hand weed their fields when that gets in there. And I've heard of farmers in the South that have to abandon fields. That they just
And they'll sprout back from the stem.
yes. Foxtail was a real problem last year because it was a wet year. We see a lot of it then. Giant ragweed is in the middle on the right. It is once it gets established in the field, it's very difficult to get rid of it. Mare's tail, I don't have a picture of it. It looks a little bit like a horse tail with the short hairs serving as the leaves. Lower left, there's the hemlock. That's been a relatively new weed that's really flourishing on the edges of fields, the edges of woods. It's a nasty plant. If you get it on your skin and you're sensitive to it, it can cause some necrotic tissue in your skin. It just eats a hole in you. Lambsquarter, the lower right, is sometimes used for food. I'm told it tastes good. I don't know. Probably not going to find out.
Not bad. Eat it raw.
Morning glory, I don't have a picture of it, but it's another one that is hard to get rid of because it establishes itself as a rhizome underground. One thing we've run into with the herbicides, every year we got a new flock of names of the herbicides that we purchase. And so we have to go through the labels and figure out what they are. And what they are is a new mix of herbicides that have been around for 40 years. We don't really have a new mode of action. I think it's Dow that says they do have one this year, but I've not heard much about it. Other thing we've seen with herbicides, before there was virtually no regulation. They just had a recommended application guide for the farmers. They were dumping it into their own sprayers. Now we have regulations requiring attendance on classes. They have to take tests. There's restrictions on when you can apply certain chemicals as to wind direction, speed, temperature, and even the weather forecast. And overall, that's been a good thing. The thing we are seeing is that weeds are evolving. They're getting resistance to certain chemicals, as well as maybe some resistance to the genetic modifications we're making to the plants that would apply to more insecticides. The maybe important thing to understand about herbicides, it's they generally go into two camps. There's chemicals that will kill broadleaves very easily, and there's different chemicals that will kill grasses. There's a few that you can apply that will kill both, but still not kill your crop. An example would be something you probably use crabgrass killer on your lawn. That's a chemical that kills grass but leaves your lawn grass. There's another Roundup type chemical that will kill everything, with the exception of the GMO plants that have the trait to overcome that. It used to be we would buy the seed and then decide what chemical we want. Now, when you buy the seed, you've pretty much determined what herbicide you're going to use, because if you have Roundup resistant crops, you're going to probably use Roundup, or glyphosate is the generic term, on that crop. And there's a number of other chemicals now that you match the genetics with the herbicide. We do have problems with some of the chemicals we use getting up and moving down the road. Dicamba is one. It's only been used for, what, 3 years now?
Well, and genetically modified soybeans.
For soybeans, yeah.
Dicamba's been around for 50 years.
Right, but it was applied on corn early, before soybeans were ever planted. And so it wasn't an issue back then. If it went down to affect your neighbor, your neighbor's corn was up, but his beans weren't planted either. And now we're applying this to soybeans that might be knee high or taller. So the volatilization and drift have been a big issue. Insecticides, this is where the GMOs have really taken over. I don't know how many farmers still apply a granular insecticide at planting. They're more relying on the genetically modification of the corn that kills the rootworm, the corn borer, the earworms. It's harder for them to get to, but they're kind of protected inside the ear. But those are three of the big pests that we're dealing with. Going back to the seed coatings, the primary seed coating used to be just a fungicide. Now we include an insecticide coating to protect that plant if it's going to be in, or the seed if it's going to be in the soil for a long time. Is you can apply a liquid insecticide. Like I said, it used to be a granular, would come out of a separate box on the planter attachment. It's applied at planting or when the crop is already up to control insects. The danger point for corn is when it's pollinating, the silks are out. That pollen on the silks is like candy to Japanese beetle and the rootworm beetles. So a lot of farmers will aerially apply insecticide at that point. Fungicides, the economics are sometimes a bit more questionable. We know they generally pay on as a seed treatment. Sometimes they pay on corn to control some of the different fungus. Beans may be a little more questionable. Sometimes in other cases they definitely pay. Moving on to harvest equipment, just some quick pictures of the machines. Corn, you're stripping the stalk down between like two fingers to pop that ear off of the stalk. Soybeans, you have kernel, the oil seeds are growing all the way down close to the ground, so you're shaving that entire plant off at the ground surface, putting it through the thresher to separate it. We're getting into the final topics. I think if we keep on moving, we can just touch on a couple of things and then move into the questions. Soil health, we've touched on it through the various points of this presentation. You think it's easy to understand. If you got a healthy soil, that's what you want. If it's unhealthy, it's not what you want, but how do you define it? That becomes a little more difficult. We've heard speakers talk about their research on the populations of microbes, bacteria versus fungus. They know having it there is good. They know that not having as much of it there is not fatal. They're just finding different results. There's no concrete definition of how much you need to have of what type of microbe. It's kind of a moving target at this point. The research is continuing, but we know that soil structure is key to soil health. Dense, impermeable soil is bad. One that has a cookie crumb or cake-like structure is good. Organic matter is huge when it comes to being able to retain moisture. I've seen farmers compare their organic matter maps with their yield maps, and there's a definite correlation. In terms of measuring soil health, we've seen some studies that try to measure the microbe respiration, which say the more respiration, the better. But the soil conditions in terms of what you think is a soil healthy field can vary widely by location within that field or even in the same location over time. The sustainable, regenerative, the stewardship, all big topics now. Our perception of the soil has changed. We've always been concerned during my lifetime anyway about the loss of topsoil, loss of organic matter, and that some people argue the nutrients that we're putting in today's food is less than what it used to be. The hypoxic zone in the Gulf of Mexico is a big issue. A lot of the issues, the nitrates, the fertilizers getting into the river water, going down to the Gulf and causing the algae to use up all the oxygen. The pathway for a lot of that is the drainage tile that we've put in to improve our productivity is a faster gateway for that stuff to get into the river water. And then the climate change is always a topic, and we're not going to pretend to be experts on that, although the state climatologist does say that over the last 30 years, our growing season has increased by about 9 days.
Cover cropping is a big topic now. We do use a lot of it in the organic systems, and we have farmers now are adapting it in the conventional systems. Quickly define it. You plant a crop with no intent to harvest it. 60, 70 years ago, maybe longer, they called it a green manure. They didn't really understand what they're talking about, but we're becoming much more aware now how much nutrient that the crops cycle and recycle and make available to the next growing crop. Most cover crops are planted after harvest and they terminate before planting the desired crop. And they can either be terminated either by Mother Nature or with a herbicide. The goals to determine what to plant is it for erosion control, the soil's health, weed control. It can be all of them. There can be any individual one. Cereal rye is the easiest to do because it's the last thing that can be planted in the fall. In Central Illinois, you can go up to the middle of November. We actually had some that we planted in January this year that had a decent survival rate, but it's obviously the earlier the better. It gets a little more difficult in Northern Illinois. Cereal rye and some of the other cover crops, the reason we use them organic in the conventional system, there's an allopathic effect on the weeds, which means those plants will secrete a chemical that is suppressive to the weed germination. So that's one of the big things that's made the cover crop successful, and then keeping a live root on the soil as long as possible will feed the soil mycorrhizal fungi and the bacteria for soil health and add organic matter, because if you have a live root, it is exuding sugar in exchange for nutrients with the biology, which what makes the system go round. The downside of covers, it must be planted early enough in the fall to establish. That gets difficult in dry years and wet years. It takes time in a busy season. Some farmers say it's an extra expense. I look at it differently as, okay, if I spend $25 or $30 an acre on a cover crop that suppresses weeds, that's $25 or $30 I don't have to, may not have to spend on herbicides, and it might be all the expense I have. And it also benefits the landowner as well as the farmer, because you're taking better care of your soil, improving organic matter, soil health, and such.
If I can jump in, Rob, you say, well, if it's a benefit, why is it a downside? Well, most landowners expect the farmer to pay for the cover crop, and the landowner's getting the benefits as well as the farmer. So it gets into who's paying it and who's getting the benefit and not paying for it.
One of the least modifications that needs to be talked about.
We'll talk about that on Thursday.
Mm-hmm. Cover crop can keep the soil from drying out, or it can dry it out too much. If it's in a dry year, cereal rye sucks a lot of water this time of year when it's pollinating. And if it's a wet spring like last year, it can keep the soil from getting sunlight and drying out, so it can get a tractor on it. So it's a double-edged sword, but it's also a good thing.
This picture is of a farm that I manage. It was taken probably 2 months ago now. What we did there, I had an airplane fly over the standing corn in early September and threw cereal rye out on this field. It's you can't tell from the picture, it does have some slope to it, and there's a neighboring agro-tourism site that has a pond. I really did not want to see my topsoil going into their lake, so I wanted to get a cover crop on there. And so this was not worked into the soil, it was just thrown on the surface. It was pretty much imperceptible all fall, but this spring it came up, and I should have taken another picture about 3 weeks later because it's pretty much solid cereal rye. Just to wrap up on the soil health, it's really something we've only focused on the last 2 or 3 years, and the research sometimes has conflicting results on what we're supposed to do. The cover crops were supposed to reduce the nutrient runoff, but sometimes we're finding that the improved permeability of the soils means that we're actually putting more nitrates into the tile water. So there's more studies that need to be done.
An interesting observation on the farm that my sons took over this year. They planted cereal rye in the corn stalks, and it's a river bottom flood farm. 10 days ago, it'll be 2 weeks this coming Saturday, the river was running through the field, and where the water was running out of the field, it was clear. I took a picture of that and sent it to the landowner, and she was just ecstatic because normally that would look like chocolate milk running out of the field. So definite benefit. Told the boy, I said, maybe when you're my age, that slough will be filled in enough and water won't run through the field.
We're going to move through this pretty quickly. We've been talking for an hour now. Commodity marketing, when you produce a crop, you've got to do something with it. We have a country elevator system out there. They're either a cooperative model where the farmers share the ownership. They're sharing the profits or dealing with the loss themselves because they own the business. There are private companies that operate these things. And they used to be serving as a feeder to the ultimate terminal, the processor, the shipper. A lot of farmers are now big enough that the terminals don't mind them bringing their product directly to them. These elevators operate on a margin, so if they're buying grain from the farmer, they're going to sell it to the processor at a slightly higher price to cover their cost. In terms of processors, we've got ethanol plants scattered around the state. We've got soybean plants that separate the beans into oil and soybean meal. Some of that soybean oil now can be used for biodiesel. The corn gets shipped by rail, most typically to cattle feeders in the Southwest. We've got the river system, the barges that are the conduit to getting our grain overseas. We'll get into maybe a little more detail now on Thursday, but you have the ability to set your price well ahead of even planting a crop or well after you've harvested it by using a broker and the Chicago Board of Trade price. Actually, it's more accurate to say the Chicago Mercantile Exchange is the name of the business now. But you can use various marketing techniques so you know what your price will be. Of course, you don't know what your yield is. We're about wrapped up here. I want to make some comments on what we're going to see in the future. We've been replacing labor with machines for over 100 years. That's going to continue. What's changing now is the robots. The picture there is the lower picture that I took of a machine over at the University of Illinois. A professor there is developing this to run down the row underneath the crop leaves. His vision is that the cameras would recognize weeds and then use a squirt gun type of device to give it a shot of herbicide rather than blanket the whole field with weed killer. The master slave system, my wife pointed out, some people might find that offensive, but it's an engineering term. You might have a driver in one tractor and he'd be followed by 3 or 4 tractors that are operating based on their distance from that machine. To have one person then could triple or quadruple the amount of work that they can do. Remote sensing has been around a while. Airplanes, now we've got drones. Satellite technology keeps improving. The genetic modifications are going to continue. The companies keep working on new genetics that will give us more yield or other modifications, nutrient content, who knows what's coming. The organic market is kind of going the other direction, away from the technology, but we're still using new techniques. At some point, you have to wonder, will that organic market become saturated? We've already seen it with the organic dairy, where there was enough to go around, and the organic price started to go back down to the conventional price. Alternative crops, we thought industrial hemp might be a big thing. It turned out to be a little bit too big of a thing. And last year, we swamped that market in 1 year. Foreign competition is always going to be a problem. Brazil, Argentina are pretty fierce competitors for our production. I think our biggest problem in our agriculture is going to be we have too much capacity. We are going to continue to produce more than we need. With that, we're going to stop talking and see what kind of questions we have.
Well, thank you, Rob and Kent. I thought that was a really good overview. And like you said, trying to cover such a complex system in a very short period of time is a huge challenge. Thank you, big thank you to your wife for sort of enduring that and helping you do that, because I think you covered a lot of ground in a really succinct, good way. I did have one question here. It said, are there cases where fields have simply lost the organic matter and fertility needed to continue farming after years of row crop farming? In other words, if you use a conventional system relying on fertilizers and so on, can you eventually just get to the point where the farm can no longer grow plants?
Not here in central Illinois or even over most of the Corn Belt. If you get to the fringes of the Corn Belt where your soils are more fragile, that I'd say is a definite possibility. Okay. Where you can just, your yields are probably not very high to begin with. And if you lose some water holding capacity, it could get to the point where you just economically can't compete with the deeper topsoils that we have here.
And we saw that pre-Civil War time within the Southeast with cotton, where the kids can continue to grow cotton. But at the same time, they didn't have the knowledge that we do now as far as fertility management and such. So can it happen? Yes. Is it likely in today's world? No, unless the price of inputs becomes to the point that a farmer can't justify maintaining these weaker soils.
You know, it's interesting on that same topic. The University of Illinois has what they call the Morrow plots, where they started planting corn in the 1870s, I believe, and they have grown corn every year since then without applying any fertilizer. And those yields, as you would expect, went down and down and down. But then in the last, I think it's 10 years, they've started to go back up. And as a result of the genetics, giving the plants are better able to handle that stress in the low yield environment, they've actually, it's still low, but they've gone from maybe 10 or 20 bushels per acre back up to 50 or 60, the last ones I saw.
Wow. I have a question here. Do you have any concerns about using lime recapture from water sanitation facilities for ag use?
Yes and no. Depends on the where it came from. I know up in the collar counties, it's a well accepted practice. You have to be careful with if it's coming out of a sewage plant or a water filtration. There is a possibility of heavy metals from both in an organic system. When I say organic system, I mean organic farming. You have to be very careful about using sludge. In fact, I just won't do it because of the risk of contamination to it, depending on the crop.
Got it. And another question. Do your landowners ask for any environmental indicators about what's being done to the land, like soil health or any other indicators? Are they asking for like any indicators related to what's happening on the land and the soil?
We have one family that is intensely focused on that, and it's been frustrating for us because they want definitive answers, and right now the technology has not caught up to where we can give them definitive answers. It goes back to my soil health discussion. They want to say, okay, you know, what did it used to be and what is it now and where do we need to be? Well, we can't give solid answers. There's no numerical scale that I'm aware of right now that would prove that.
Same with soil fertility tests. You can take the same soil sample, break it in 3 different samples and send it to 3 different labs and get 3 different answers. So it's there's no definitive answer to that.
You have to look at the evidence, and I guess the attorneys would use the term preponderance of evidence as to what you have, what you're dealing with. Got it.
I guess one of the things that strike me, you were showing so many photos of equipment of various kinds. And farmers are farmers primarily to grow things. How do they maintain their equipment? Do they maintain everything? Do they fix things? Or do they have to rely on other service providers?
Yes. It used to be a farmer could work on their machinery pretty easily, but just like your car, the technology, computers and such have come on to the machinery for your guidance systems, for your emissions controls and such, and to control the transmissions. And it's getting increasingly difficult without spending a lot of money on technology in the shop, your farm shop, to work on the newer machinery.
If you take your car in for maintenance, the first thing they do is plug the little reader in to see if you got any error codes or all of that. It's
Tractors and combines are the same way.
yeah, the mechanic will bring a laptop out to the field if you're broken down and plug it in, and they can even do that
remotely.
Remotely.
Out in South Dakota, I had a farmer, his combine was sitting in the field one night, guy actually struck by lightning. Only had to put 7 new computers on the combine.
Oh, ouch. Ouch. Well, while I have a few more questions, but we have another one. Okay, it says, are you concerned that the farm community will be held responsible for siltation and water pollution in the future?
I don't know if I'm concerned. I'd say it's a fact, and they probably should be. That's why we don't moldboard plow anymore, is because the soil erosion was just horrific. You look at the dust storms down south in the 1930s, there was a direct result of the moldboard plowing. We went to the leaving more residue on the surface of the ground to protect that erosion, or from that erosion. But yeah, I guess the farmers have to be accountable for what they're doing, because we have impacts on other people downstream.
The difficult part is defining agriculture pollution or soil erosion is considered non-point. It's pollution because it's hard to say, well, it's all coming off this field or that field. It's coming off all the fields.
Right.
So it's not like a factory that's sitting along the Illinois River spewing out toxins into the river, because you can measure it coming out of the pipe. You can't measure effectively what's coming off each field. So,
Got it.
I mean, the farmers are somewhat being held accountable now through the fertilizer tax that's used to help educate ourselves on, you know, fertility management, cover crops, and such like that. So,
yep. Like, if thinking about it from a farmer's point of view, how much of a gamble are they taking every year as far as when they choose seeds or choose what crops to plant? They've got markets. Like, what kind of calculation goes through their mind, and how much psychological stress is there for them?
A
lot right now.
Yeah, the stress is huge. You never know what is the right choice ahead of time. You might choose a corn hybrid that does well in a dry year, and you have a year like 2019 comes in, and you would have done much better choosing a hybrid that could deal with the wet soils. So we'll get into the risk management in the next presentation. But so you plant a little bit of both.
Generally, a farmer, you know, buys everything wholesale, or excuse me, retail, and sells everything wholesale. So it's a thin margin right now with commodity prices where they are. Most farmers are operating at a loss right now if it was not for government subsidies. And anytime when we're running budgets, and we'll talk about this more on Thursday, but a lot of times a farmer's only looking to maybe make a 8 to 10% return on the amount of money that they invest. And they have, when you figure whether they own the land or rent the land, they've got a lot invested in land and all the inputs we've talked about, plus machinery, plus their family living expenses.
Yep. That's a lot resting on a decision far in advance. That's got to be tough. While I'm asking a few more questions, if anyone else has any more questions, they can put it in the chat. If you wouldn't mind now showing your video, just so that our presenters can kind of see you, actually the anonymous people who have been watching them, that would be awesome. I think you have the ability to sort of make yourself visible. The other question I would ask you is, most of the row crop farmers they're like a second or third or fourth generation farmer. What keeps them in farming, and like what gives them satisfaction? Is it for sort of keeping that legacy alive, or what are the other ways they get satisfaction from what they do?
Well, in some respects, it's a closed society. unless your family owns farmland, there's very few people, unless you're Bill Gates or some other moguls that have cash available.
Yeah.
It's very hard to go out and buy enough farmland to have a viable operation. So the reason you have it passed from generation to generation is that it's the only way in.
Oh,
See, my sons are seventh generation on our farm in Green Valley.
so Rob, why do your sons farm?
This is their first year because family legacy, because they want to.
Okay.
They both have off-farm jobs, but it's one of those things. They grew up on the farm. It's one of the things they've always wanted to do, and this was their first opportunity to do it because I got out of the bad. I gave up the bad habit 25 years ago.
Yeah, there's something immensely satisfying about going through the life cycle every year, putting that seed in the ground, watching it come to fruition, dealing with the problems when you successfully deal with them. It goes to my theory that the happiest people in the world operate bulldozers because they see immediate results of their work. And farmers, it's also not always as immediate, but they get to see the results. Whereas Rob and I, as farm managers, we're on the phone, we're on our emails, we're driving around looking at things, and it seems like it just never ends. We wonder if we're ever accomplishing anything some days.
But I also enjoy getting in the tractor too. The sons had to teach me how to drive the tractor because they had auto steer on it. I've never done that before. It's like, oh, just kind of line up there, push the foot pedal like loose to the steering wheel and go. Like, really? It's not the way I did it when I farmed.
So what this is probably a hard question. What separates the successful farmers from the ones who are maybe having a harder time?
The profit.
In terms of
management,
I think more of it's just attention to detail.
Okay.
There are some farmers I work with that I know that when they wake up in the morning, the first thing in their mind is how their crop is doing. They're out there in the field every day. They're seeing what's going on. There are other farmers that there's a certain segment of them feel entitled to farm because their family has farmed.
Right.
And they plant seed in the spring. That maybe hire some crop scouts to do their scouting for them, which is one way to do it. But they just don't have that passion that some people do. The guys that are really successful, they have a drive to succeed that other people don't have.
Just like any other business, Nathan.
Yes.
Okay. And any insights about what you've learned from working with landowners? How are landowner attitudes and thinking about agriculture changing?
Well, we're in a generational shift now, and that was a big driver for us to get into the organic movement. We saw the younger generation coming on. The organic food issue is an important one to them.
Yeah.
For my age, I thought it was just a passing fad. I decided differently here a few years ago. I said, no, this is here to stay. We need to either get on board or forget about it. We decided to get in it. So the generational shift is big. Just in terms of generally working with our landowners, we need to know what's important to them. We do have a number of clients that they're investors. They look at the return on investment and not much more. Yep. We have other people who largely worked in sales. They're very much people oriented. They enjoy knowing their farmer. They want to know how his family's doing. They want to know how my family's doing. They just they live for that interaction and that they get to live that life cycle too of the planting to harvest.
As Kent mentioned, we are in one of the largest generational shifts of land ownership, and depending on the number of people in the family and is there a legacy after that, whether the farm is retained or some of the family retains the ownership and pays out some of the other. Some of it's a legacy thing. Some of it is it's a legacy and an investment. So we're going to treat it that way. We want to get the good return on it as we can because some of them that's a retirement income. Right. Because of corporate changes or whatever, they've lost their pensions or there's a lot of things going on in there. There's an old statement that all true wealth comes from the land. So that's how each landowner views it differently.
Mm.
They also view it the same because, well, it may not be the highest return, but I can at least go out and walk on it and look at it, and they can't it can't disappear overnight with a stock market blip. So it's a diversification.
Illinois has a program where if you can prove your family's owned some land for 100 years, for $50, they provide you a sign. You have to pay to put your name on it, but I've helped several clients obtain those signs. And when I see them look at it for the first time, you can really just sense the powerful emotions that are churning through them, because that really brings it home that this has been their family legacy.
My parents worked real hard. We're real excited in 1972 when we got the centennial sign, and my dad was more jubilant when we got the sesquicentennial sign a few years ago. So I mean that is prominently displayed at the end of the driveway. So
okay. All right. I don't see any other questions. I'm going to ask one last question, and then so you've helped some farms transition to organic. What are some of your big lessons from that process that might have even surprised you? What surprised you about that transition process?
That's a really loaded question. It's so different in what we have to go through on transition. The biggest challenge is working with tenants, making sure you have a tenant that's willing to do it, if not, finding the right tenant to do it, and then working with how do they get rewarded for their time and effort. So we have, I promote if we're going to do an organic transition, if the landowner can do it, afford it, switch to if it's been on a cash rent, switch back to a crop share lease, because I tell them that is what shows the tenant you're willing to put skin into the game, you're serious about it. Some are on a custom basis, so we're paying a farmer to do the work, but we're also giving them a part of that income as an incentive for them to be there timely to do it, because timing is everything in organic. So it's designing the system for the farm.
Got it. Kent, do you want to add anything to that?
I think and I don't know if it qualifies as a surprise, but in talking to organic farmers before I ever dived in, a lot of them talk about the field that they never were able to harvest. So I just have to make sure that the landowner and the farm tenant are prepared for disaster, that tell them that a certain amount of disaster is normal, and we're not going to sue them or fire them just because we have a bad weed in one field one year, but because everybody has to go through that learning curve.
Awesome. Well, thank you so much. This has been great. Thank you everyone for taking part in this. Part 2 is coming up on Thursday, and I think we're going to hear a lot more about other elements of the system that are really important for farmer success and the things that they're thinking about in terms of their business. I hope this has been super helpful. This will be recorded and eventually shared as well. And special thanks to both Kent and Rob for your hard work on sort of trying to condense all this complex information and sort of giving us a good overview that doesn't get lost in the details. So we will see everyone on Thursday. Friends, have a great day. Take care.